You've previously learned that if a psychological researcher is using a correlational method, the study can uncover whether a relationship exists between variables. The resulting data will let the researcher predict how these variables are related in the future. However, the researcher will not have control over the situation, and so cannot explain whether one variable causes the other. Therefore, if the goal of the research is to determine causation, the psychologist must use experimental methods to test the hypothesis. In this section, you're going to learn about experimental methods. To begin our understanding of experimental methods, we're going to return to the research example about whether using a cell phone while driving affects driving performance. So let's say you design an experiment in which you control whether people are using a cell phone and you measure driving performance. You could also add other conditions to try to understand why this effect occurs. Is it because of holding the phone or because talking on a cell phone is distracting? In this case, you might want to have two experimental conditions. In one condition, participants use a handheld phone. In the other, they use a hands-free. Your new hypothesis might be using either hands-free or handheld cell phones impairs driving. But how would you examine this hypothesis? To perform an experiment that will test a hypothesis, the researcher manipulates one variable. This variable is called the independent variable. In your experiment, the independent variable would be using a cell phone. You would manipulate how your research participants use or do not use their cell phones. After manipulating the independent variable, you would measure the effect of that variable has on a second factor. That second variable is called a dependent variable. In your experiment, the dependent variable is driving performance. Instead of letting your participants drive, you might measure their performance safely as they use a driving simulator or even play a driving game on a computer. To ensure that the research is objective and systematic, you have to define the variables more specifically. In other words, you must create operational definitions of the variables. Operational definitions qualify and quantify variables so that they can be understood objectively. For example, how will you qualify or describe cell phone use in this study? Do you mean holding the cell phone or using it hands-free? Do you mean talking, texting, reading, or some combination of these activities? In addition, how will you quantify or measure cell phone use? Will you count the number of times a person uses the cell phone in an hour? Or will you count how long a person uses it? Or even how many different activities the person is engaging in while using it? All of these decisions need to be made before starting your research so that you can be clear about how the independent variable is manipulated. Just as you need to operationally define the independent variable, you also need to operationally define the dependent variable. In your experiment, the dependent variable is driving performance. How will you quantify and qualify driving performance so that you can judge whether it's affected by cell phone use? Do you rely on people's self-reports of performance, or do you use observational methods? If it's the latter, you'll record the speed of driving, the number of accidents, the closeness of cars up ahead, or the reaction time to red lights or road hazards. One option for the dependent variable might be to measure the amount of time it takes participants in the driving simulator to stop the car when an obstacle appears in the road. In this case, the operational definition of driving performance is in milliseconds of stop time. But often, a single dependent variable can have many operational definitions. So another operational definition of driving performance, even in the same study, might be how many times the person playing the driving game crashes the virtual car. Deciding on clear operational definitions will actually let other researchers know how you measured your variables. And knowing your methods, other researchers can use identical methods to gather data that will build on your data, either supporting or differing from your results. The use of operational definitions, then, is crucial for those trying to replicate the research findings. So now you know that your experiment will test the hypothesis that the dependent variable is affected by the independent variable. But how will you know if the change in the dependent variable is really caused by your manipulation of the independent variable? To clarify the relationship between your variables, you assigned some participants of the study to a control group. In this case, participants assigned to the control group would not use a cell phone while they're using the driving simulator. This is the baseline condition. The participants in the experimental group will experience the manipulation that you're interested in. These participants will get the treatment in the experiment. In this particular experiment, you could use more than one experimental group so that each one is exposed to a condition that requires different use of the cell phone while driving. One experimental group might talk on a hands-free phone, whereas the other group might talk on a handheld cell phone while driving in the simulator. You would then compare the effects of driving without using a cell phone in the control group with the effects of using a cell phone in the two different ways of the experimental groups. In the experiment that's been described so far, different people have been in the control and experimental groups. This type of experiment is called a between groups design because different people receive different treatments. However, sometimes study participants serve as their own control group. Within subject design, the same people receive all treatments. For example, people would be tested in the driving simulator once without a cell phone, once talking on a hands-free cell phone, and yet another time when talking on a handheld cell phone. In both between groups and within subject designs, the goal is to determine whether differences in the performance are caused by the different treatments. A disadvantage of the within subject design is that repeating the test means people experience the task multiple times. This repetition could actually influence their performance. For example, people could improve in the driving performance on the simulator each time, regardless of whether they use a cell phone or how they use it. Such improvement would make it difficult to determine the exact relationship between cell phone use and driving performance. By contrast, in your experiment, a between group design enables you to draw clearer conclusions. The benefit of using an experimental method is that the researcher can study the causal relationship between the two variables. Suppose the independent variable, which is how the cell phone is used, consistently influences the dependent variable, driving performance. The independent variable is then assumed to cause the change in the dependent variable. The experimenter always manipulates the independent variable and then measures the dependent variable. That is, manipulation of the independent variable comes before the dependent measure. In this way, the experimental solves the directionality problem that would occur in a correlational study. You will also now learn about how experiments make it possible to rule out alternative explanations such as third variables. Only experimental methods let a researcher achieve the goals of control and explanation. Indeed, a properly performed experiment depends on rigorous control. Here, control means the steps taken by the researcher to minimize the possibility that anything other than the independent variable will affect the experiment's outcome. That is, when conducting an experiment, a researcher needs to ensure that the only thing that varies is the independent variable. That way, the researcher knows that the independent variable, nothing else, has affected the dependent variable. Anything that affects a dependent variable and that may unintentionally vary between the study's different experimental conditions is known as a confound. A confound can be a potential third variable in your study. Consider a confound in your experiment on cell phone use and driving performance. Suppose that the driving simulator is used by participants in the control group has an automatic transmission. Now suppose a different driving simulator, one with a manual transmission, is used by participants in the experimental conditions. If you're not familiar with both types of transmissions, you might think that they're equal. However, driving a car with a manual transmission takes more skill than driving one with an automatic. As a result, a change in driving performance might actually be caused by the type of car used in the driving simulator. In this example, the driver's performance might be confounded with the type of transmission. The presence of a confound would make it impossible to determine the true effect of using a cell phone on driving performance. The more confounds and thus alternative explanations that can be eliminated, the more confident a researcher can be that the change in the independent variable is causing the change in the dependent variable. Control represents the foundation of the experimental approach because it allows the researcher to rule out alternative explanations for the observed data. As consumers of research, we all need to think about confounds that could be causing particular results that are reported in the news. At the start of research, experimenters need to consider the selection of participants. Psychologists typically want to know that their findings generalize. In other words, the results should apply to people beyond the participants in the study. When studying how using a cell phone affects driving skills, you want to know more than how the specific participants behaved. Ultimately, you want to discover how using a cell phone affects the driving performance of the average driver. The general group you want to know about is your population. For instance, you might want your results to generalize to college students, to students who belong to sororities and fraternities, to women, to men over the age of 45, and so on. To learn about the population, you study a subset or a small number from it. That subset, the people you actually study, is the sample. Sampling is the process you use to select people from the population to be in the study. The best way to represent the whole population is to take a random sample. This method gives each member of the population an equal chance of being chosen to participate in the research. If you're trying to generalize to the entire human population, then random sampling from all humans is, of course, likely impossible. Most of the time, researchers will use a sample consisting of people who are conveniently available for the study. This is called a convenience sample. Even if you wanted your results to generalize to all students in your country or in the world, you would probably use a sample from your own college or university, or in our case, high school. However, you would still try to collect a random sample from this convenience group. Even though a sample from your own college or high school might not look like all students in the country, it seems reasonable to expect that the effect of using a cell phone on driving performance would be about the same no matter where you sample the participants from. However, it is important for researchers to recognize that their results might not generalize to other samples that are quite different, such as people from other cultures. In experiments, one possible confound is that people in the experimental groups may differ in important ways. Suppose the people in the hands-free group have less experience driving than those in the handheld group. This difference could create a difference in driving performance that has nothing to do with the manipulation. One way that researchers try to make sure that experimental groups do not differ is to use random assignment to assign participants to the experimental and control groups. Random assignment gives each potential research participant an equal chance of being assigned to the control or experimental groups. To randomly assign participants, you might have them draw numbers from a hat to determine who is assigned to the control group and to both the experimental groups. Of course, there are always individual differences among participants. For example, each of your groups might include people with more or less experience using cell phones while driving and some people with excellent or weaker driving skills. If the control group happened to have many participants with less experience using cell phones or poor driving skills, then any negative impact of driving while using a cell phone in the experimental groups might not be seen. But these differences will tend to average out when participants are randomly assigned to either the control group or the experimental group. This happens because the groups will be equivalent on average in terms of participants' use of cell phones and experience with driving. So, using random assignment to balance out known and unknown factors is important because it helps to reduce confounds that could limit the ability to say that a certain manipulation caused a certain outcome.